these mid-range GPUs look almost identical on the outside. The 16 gigabytes versions, which I have here, and for local LLM chat or stable diffusion, you'll definitely want at least 16 gigabytes. But under those matching spec sheets, the story kind of splits. You can even tilt the card this way and see the differences already, especially the ports. The NVIDIA RTX 5060 has 4 outputs, while the AMD RX 9060 XT has 3. But those aren't the only differences. Since we're talking about machine learning today, the platform support is going to be quite different on these, and also the power usage is going to be quite a bit different. Now, so everything is fair to test these out, I've built identical machines. Everything's the same here. The motherboard, the CPU, which is the 9700X, same amount of memory, everything. And just to give you an idea of how these work, I have LM Studio here, and I'm gonna say write a JavaScript function to find prime numbers up to n, and I don't know why it's not familiar with the word JavaScript. That's weird. Monitor on top is my machine on the left. Monitor on the bottom is my machine on the right. They don't have any GPUs yet. Let's select a model. I'm gonna do a very simple one, Gemma 3-4 billion. And you can see that LM Studio is actually able to offload 34 out of 34 layers onto the iGPU. Now I'm taking this little tangent to show you what the iGPU is capable of for a very specific reason. We can, first of all, we'll compare it to these, and second of all, we'll compare it to another recent iGPU, which has been making some waves. And let's go. This is a thinking model, so it first has to think about what it's gonna do. There we go. And while it's doing that, you can see that this is actually happening on the GPU, on the iGPU, which is just AMD Radeon graphics here. So not the most powerful thing. 2 gigabytes available for dedicated GPU memory here, and it is being filled up by this model. And there's the compute, it's happening right here. And this is running under Vulkan. If we take a look at runtimes in LM Studio, you'll see that Vulkan is selected. And Vulkan is a set of graphical programming APIs. So you can use the GPUs to do parallel processing, to do the graphics processing, and it's cross-platform. So this will work on Linux or Windows. All right, we're pretty close. So we're at 5.4 tokens per second here and 5.13 here, with a slight variation of the number of tokens generated, but that's within the margin of error. I also went ahead and used Llama Bench, which is a tool that gives you the prompt processing speed and the token generation speed. PP512 is prompt processing. That's what it is for Gemma 3-4 billion Q4 Quant. And we got 54.11 and 53.16 prompt processing, which is a little on the slow side for prompt processing. Token generation 6.16 and 5.76, pretty consistent to what we saw in LM Studio, because LM Studio uses Llama CPP as the backend. And here's DeepSeek R1, the distilled version for Qwen 2.7 billion Q4 Quant. Sorry for all the sounds that I'm making with my mouth. I hope this makes sense. And if it doesn't, please see some of my other videos where I go into a little bit more detail about this. But suffice to say that this is pretty slow. The PP512, the prompt processing, is 26.76, and the TG128 token generation is 3.32, which is just really bad, especially because we can see that this is happening on that iGPU. Now, iGPU is, you know, it's just, it's not meant to be doing this kind of thing. However, we did see this box, and this has an iGPU in it, which is a little bit different. This is AMD's Ryzen AI Max Plus 395. I hope I said that right. And we saw the prompt processing speed over there go to over 900 tokens per second. So very different kind of chip. But let's see how these systems do with discrete GPUs, not integrated GPUs. All right, here we go. Let's run Llama Bench here one more time. I'm sending in the DeepSeek R1 Distill Qwen 7B model in there, and let's go. Wow. That is a huge difference. Holy cow. Okay. And it's not looking so great for the AMD machine right now. Even though Llama Bench is detecting the Radeon RX 9060 XT, and it's detecting the NVIDIA GeForce RTX 5060 Ti, by the way. That was Ti. Did I mention that was Ti? I should have mentioned that earlier. But that's how you get the 16 gigabytes anyway. So 2,362 tokens per second for prompt processing on the NVIDIA machine, 78 tokens per second text generation. But on the AMD, it's 1,000 tokens per second less for prompt processing, 1385, and token generation is 63 over there. Now for machine learning tasks, a very important thing is memory bandwidth. We can see 16 gigabytes of dedicated GPU memory on both of these machines. Let me run that benchmark one more time. And we'll keep an eye on the memory consumption here and the GPU workload. Here we go. Yeah. That's definitely all happening on the GPU, and we got plenty of room to go since we have a total of 16 gigabytes. So we could run larger models here. Now you don't see it here on this screen, you just see the amount of memory, but the story is actually underneath the hood there. Underneath the hood, do people say that? Whatever. 448 gigabytes per second is the memory bandwidth here, and that's using GDDR7 memory type. So it's more advanced than what we got here on the AMD GPU, which has GDDR6, the previous generation, and it only has 320 gigabytes per second of memory bandwidth, even though they both have the same bus width of 128 bits. We could stop right there, but I think we should take a look at some more workflows, especially for image generation and for video generation. We're gonna get to that in a moment. First, I wanna see what's going on here with LM Studio. Here's our old number, 5.1 and 5.4 tokens per second. That was on the iGPU. Let's quickly see how much of an improvement we get with the discrete GPU, offloading everything to the GPU. I'm gonna include all the context too, so this is not gonna be a pure experiment of what we get on the first shot, but it's going to include some of the context just for context. Alex is trying to be funny, but sometimes he's not. It's okay. Write the function itself and go. All right, this is quite a bit faster on both of them, but there is a bit of a difference. 102 tokens per second here on the NVIDIA, 87 tokens per second on the AMD. So these days I'm constantly flipping between models. GPT-4o for notes and email, Claude for code refactors, Flux for image generation, Kling for video, 4 tabs, 4 bills, and counting. Enter Chat LLM Teams. There's one dashboard that houses every top LLM, and Route LLM picks the right one for you for a given task. O4 Mini High for fast answers, Claude Sonnet 3.7 for coding, Gemini 2.5 Pro for big context, and even adds GPT 4.1 before ChatGPT has it. Chat with PDFs and PowerPoints, then generate decks and docs and do deep research all in the same chat. Need human-sounding copy? The Humanize toggle rewrites text to beat AI detectors. Spin up agents and run code with AI Engineer. I built my first bot in just minutes. Track artifacts, create GitHub pull requests, and debug from the same interface. Need visuals? No problem. Use Flux or Ideogram and Recraft for images, Kling, Luma, and Runway for video, all built in. And the kicker? It's just $10 a month, less than one premium model. Head over to chatllm.abacus.ai or click the link in the description and level up with Chat LLM Teams. I know some of you are going to want a bigger model, but we still have to work within the confines of the 16 gigabytes that's available there for the VRAM. So I'm going to pick a nice coder model, Qwen 2.5 coder 14 billion, which is around 9 gigs. That's for the Q4 version, but the Q8 version is actually 15.7. So I'm going to push it a little bit on both of these. If you're not familiar with the Qs that I'm talking about, that's the quantization level. Initially, these models come in BF16 or F16, which means floating point 16, but then they're quantized down so that they can run on smaller devices and run faster. The quantization, though, takes a hit in the quality of output. That's for another video, but just a quick little reminder of what the Qs are if you're new to this. Now, usually LM Studio warns you if the model is too large to fit in the GPU. It didn't warn me here, so I hope that it can fit fine in both of these. All right, 100%. Here we go, using chat. Oh, it's telling me that it's not wanting to offload everything to the GPU. What's up with that? Let's try it anyway. 48 out of 48, load model. Same thing here with the AMD. Boom. Hey, I think it did it. Let's do a new chat. And I want to keep an eye here. Oh, look at that. 15 out of 16 gigabytes in use. We're just at that threshold. Yeah, that's good. We don't want to go into the CPU territory because that's going to slow things down considerably. Let's do a new chat here and check the AMD. And 15 out of 16, so we should be good. What the f? Damn, I downloaded the wrong model. But you didn't see that, right? Re-downloading. Okay, 100% downloaded. Since you don't like spelling JavaScript, I'll do Python. Write a Python function to find prime numbers up to n. Let's go. Boom. Okay, this is going pretty well, I'd say. A 14 billion parameter model is decent. It's filling up the RAM really nicely. and it's going pretty fast. The NVIDIA one is done though. It doesn't mean anything. Chill out, okay? It generated less tokens, 25.71 tokens per second on the NVIDIA machine, 418 tokens generated on the AMD box, 19.77 tokens per second. So yeah, it is slower. And I know what you're gonna say. You're gonna say, Alex, why didn't you get the 5050 to compare that with the AMD 9060? Because then that's gonna be more fair, right? Because they both will have 320 gigabytes per second bandwidth. Well, yeah. But they're also not going to be able to have 16 gigabytes of VRAM each, so you kind of have to pick and choose what you need. And the 5050 is in a different price bracket because of that. It only has 8 gigs of VRAM and it's $100 less. So if you're going to be running small models, which are good for some things, models that are 7 billion parameters and maybe quantized to 4 bits, then you'll be able to fit into an 8 gigabyte card. But if you want to run larger models, more parameters, they give you better results, you're going to need more VRAM, and that's why we're here. Plus also these had 60 in the name, both of them.
I figured they go together, you know?
Now for image generation, there is a really easy program called Amuse. Do I amuse you? Think I'm funny? Funny how? Like a clown? Do I amuse you?
But I'm funny how? I mean funny like I'm a clown, I amuse you?
Anyway, it's partnered with AMD, so I wonder what that means. Is it gonna be running better on AMD chips? I just installed it on both of these machines, and I got a blue screen of death on the AMD machine. I swear, I bought these with my own money. I built this whole system with my own money. I'm not out to prove that NVIDIA is better or that AMD is better. I'm just testing these out. And so far, the NVIDIA box has been doing better, and Amuse just crashed my system on the AMD machine. Yeah, it seems to be actually working on the NVIDIA box. I'm running a generation right now. Let me try to get Amuse fixed here. Come on, don't crash on me. There it is, let's run it. AMD partner, it says right there. So it better be better than the NVIDIA one. The default prompt is a cute raccoon playing guitar in the beach. Right after you install it, I'm gonna click on generate images, but it doesn't have the model yet, so it needs to download that. I'm gonna say okay, and it's gonna download the Dream Shaper lighting model, which is 11.2 gigabytes. So that's perfect for the size of the GPUs we're dealing with here. The AMD one is downloading the model, but the NVIDIA one has already downloaded it and it's generating, but the generation is taking so long. Let me do a quick checkup on, oh, what's going on? Oh, it's not running. I was wondering why it's taking so long. It's because it's processing it on the iGPU and not using the NVIDIA GeForce RTX 5060 at all. That's a shame. I'm gonna have to cancel that generation because that doesn't help us at all. All it tells us is that it's gonna take a really, really long time if you try to do that. Now, when I did look up Amuse, it says that it supported NVIDIA. And the AMD one is flying. It's generating 4 little raccoon pictures and it's done already. Oh, here it is, here it is. Yes. It's using DirectML and I can switch it to NVIDIA. Here we go. Generate. Hey, there we go. It's working. Let's do a little race, shall we? Instead of raccoon, I'm gonna say cat. And boom. Let's go. Oh, the AMD one is faster. This is a good use case for AMD because Amuse is optimized for AMD. So it's gonna be faster, but just by a little bit. Let's switch to Linux because there is a little bit of a difference between how these models perform on Windows versus Linux. I'm gonna kick things off with Ollama run, and we've got our Gemma 3 model there. Write a Java function to find prime numbers up to n. And let's go, boom. Okay, they're both going pretty fast, but the AMD one just seems so much faster. What is going on? NVIDIA SMI should give us a little bit of insight. What? The NVIDIA driver is not loaded.
6.5 hours later.
Okay, it's been a few hours, and the reason for that is, I gotta rant a little bit. Installing NVIDIA drivers on Linux is a pain. But once you get them installed and everything's working fine, one day you'll find out that it's not, and suddenly you need to reinstall the drivers and go through the same thing. But the nice thing for you is you get to see it all done. Here we go, boom. And look how much faster the NVIDIA side is. 113 tokens per second. 65 tokens per second over here on AMD. I'm gonna have it do it again so we can take a look at the power usage. And also NVIDIA SMI. Up here we've got ROCm SMI so we can watch both at the same time while they're processing to see what's happening on that GPU. Let's go. And there you go. You can see that 150 watts is being used out of 180 on the NVIDIA card, about 150 on the AMD card as well. And 100% of the GPU was used on the AMD card while that was processing. Now, as for power draw for the whole system, here we've got 66 watts on the AMD side. We've got 69 watts on the NVIDIA side. Let's kick this off. There they go. And now we're up to 120, 220, 250 on the AMD side, and 265 on the NVIDIA side. Not much of a difference there. I thought it was gonna be way more of a difference, but it's not. Yet, we're still more than two times faster on the NVIDIA card than the AMD card. Now that was text generation. Let's switch over to image and video generation. I've got Comfy UI installed here. I just started using it, but it looks like a lot of fun, especially if you like tweaking these little levers and knobs. Basically, it's highly configurable. If you go to download here, you only see that you can download it for Windows with NVIDIA cards, or you can download it for Mac, requires Apple Silicon. But your other option, if you don't have one of those, you can install it from GitHub. So I'm on Linux here, which means I have to install it manually on both of these systems. And that's not that hard. You just go to the Comfy UI GitHub page and follow the instructions. There's the manual install instructions for AMD GPUs, Linux only, and then NVIDIA GPUs. And this is exactly the steps that I followed. Now, I did run a test on this already, and it may seem like one of them is not using the GPU at all, but it is. It is. Let me show you. Here I've got an image generation pipeline. Beautiful scenery, nature, glass bottle landscape. All right, that's the default. I'm gonna just generate that, and I'm gonna do it on both of these at the same time. Let's go. Excuse me, the NVIDIA one is already done. Here we go. Executed in 1.35 seconds. That's how long it took to generate that image. That's 512 by 512 on the NVIDIA box. And it took 8.99 seconds on the AMD machine. A lot slower. Now, I also ran video generation, and the reason I'm not doing this live is because it takes a while. Both of these take a little bit of time, a little longer than your image generation. Here's the output of the NVIDIA machine. We've got a guy playing guitar in a subway. By the way, this is Video WAN 2.2, which is a brand new model, brand new nice video model. Can't wait to play around with this more. If you want to see more videos about this model or any specific model in general, just let me know in the comments. It looks pretty good. This is the small model. It's the 5 billion parameter model. And yeah, there's a guy playing in the subway. There's some weird stuff going on there. Like, who's that guy walking around? I have no idea. There's some guy just like walking backwards in the tunnel. But yeah, you get a sense of what's going on here. And on the NVIDIA box, this took 566 seconds to do. Okay, you're waiting for a video. You can wait a little longer. I suppose that's doable, right? By the way, this model is about 15 gigabytes. So just under the limit of what this card can hold. Both of these cards, actually. Now let's take a look at the AMD output. And I have a feeling you're not gonna like it, because I didn't like it. So I'm just, projecting what's gonna happen. So here's the video, check it out. What the heck is that? Same exact model, same amount of video RAM. There's a guy playing guitar, but the whole video is very not clean, That is not the kind of video I want to see. It's like really abstract and artistic, or maybe it's just like something that you copied from VHS to VHS 20 times. You ever done that? I've done a couple of bounces, but that was a long time ago. Doesn't look good. And to get this crappy image, it took 1 hour and 48 minutes. Yeah, so something's got to be wrong here. My spidey senses are tingling, thinking that this is probably not running on the GPU. However, if I look at the logs here, it was. The encoder model is CUDA, the VAE load device is CUDA, and I can watch ROCm SMI as it's generating. So let's take a look at that. Right now, the GPU usage is 2%. I'm gonna kick off this pipeline one more time just to show you what's happening with it. And right now the GPU is at 100%. AMD system is using 210 to 220 watts of power for the entire system. Let's try the same thing over here and run this one more time on the AMD GPU. And this one's using 278 watts for the whole system. Looks like 163 is going to the GPU only. By the way, both of these GPUs are capable of about 180. It's 180 for the NVIDIA, but 182 watts for the AMD. About the same. So the GPU is being used at 100% over there on the AMD, which tells me that something's probably running on the CPU over there, which would account for the speed. So why is this workflow not using the GPU to its fullest? I don't know. It is definitely running on the GPU, and I could tell, I could hear it on both of these. It's clicking away over there. It's not as loud as the 7900, but it's there. It appears to me that the AMD workflow is not yet final here, even though this is running the latest version of ROCm. You know, I couldn't just leave it there. We had good success with AMD on Windows through Amuse because it was optimized for AMD. So I went back and I ran some video generation here, and look at that. Both have really good results. Now this is only a 5 GB model, small model, but it's giving me what I asked for. A cute raccoon playing a guitar in the beach. It says in the beach, that's the default text. I wish I was in the beach right now. I mean, that looks really nice. It generated 4 videos, 2 seconds each. The AMD one did take longer, but it created this cool double neck guitar, and the NVIDIA one did not. One more test and it's gonna be a race. I wanna do one video that's 6 seconds long, because 2 seconds, it's like, who needs that, right? And we're gonna compare the speeds. Go. Yeah, you can see it right there. The steps, the NVIDIA machine is way, way faster. There's a total of 64 steps, we're on 20 now, and AMD is only on 5. Now, even though this program is optimized to run better and faster on AMD, we saw that with image generation, it works better. That's the only use case where AMD won, is image generation with this program that's super optimized. But video generation, we're back to NVIDIA winning. Look, NVIDIA video is done already. It's playing the 6-second raccoon clip, but we're only on step 20 out of 64 on the AMD machine. So yeah, the speed of these is very different, but let's say we were comparing the RTX 5050 instead of the 5060 to the 9060 XT, because those would have the same bandwidth. Will be $100 cheaper on the 5050, and at that point, you're wondering like, well, how much do I want to spend on the GPU? If I only have 250 bucks, I'll buy the 5050. But if I have 350 bucks, then I won't buy the RX 9060. I'll go for the RTX 5060. Now, given what you've seen so far in this video, what would you do? What would be your choice? And there's our raccoon. It took way longer, like 4 times longer on the AMD machine. Now, I did make a pricing mistake earlier in the video, since I was pricing out the 5060, not the 5060 Ti. This is the Ti, which comes at $100 more at 450 bucks or thereabout. So that's 100 bucks more than the 9060 XT. And given what you know now about these two cards, which one do you think is more worth it? Of course, if you're limited by a budget of 350 bucks, then you know what you're getting. Probably the AMD card. Also keep in mind that you're gonna be facing a few challenges. First of all, the graphics DDR memory that's in that is 1 generation older than on NVIDIA machines, which is gonna have an effect on it. Maybe not as much as the memory bandwidth and the amount of RAM, but the biggest obstacle to AMD is still support and optimization in software. And yeah, you could buy into the future idea that AMD is going to get on that, and they have been, but it's just taking a long time. And every time I look for a library that I wanna run on Windows, usually I come across NVIDIA drivers, software that supports CUDA only on NVIDIA. Here is a Llama CPP is a good example of that. Right now it does not have ROCm support on Windows, only on Linux. Let me know what you would get. And there is another 16 gigabyte card that's actually a lot faster than the 9060, and that's the 9070. I tested it out in this video right over here. If you want to check it out, go click on that. Thanks for watching, and I'll see you next time.